First, let's look at the payoff from exercising a call option. We can say it's either the maximum of ST minus E or 0. Well, what does that mean? Well, S sub t is the stock price at time t. So let's assume that right now we are at time t. In order to solve this thing, we'd need to know what is the current stock price. We'd also need to know what the exercise or strike price is. By the way, E here stands for exercise, but you may also see the letter K used for strike price because K in baseball means strike. I'm not sure how baseball and options got mixed up, but there you are. Okay, so what are we going to do here? The maximum of S sub t minus E or 0. Well, what does that mean? It means that if S sub t is greater than E, then we go with S sub t minus E because it's going to be positive. But what if S sub t is below E? Then that term on the left is negative, and the maximum of those two would then be 0. If S sub t is greater than exercise price or strike price, then we say that the call is in the money, meaning that you can actually get a payoff from exercising the option. However, if the stock price is lower than the strike price, then the call is worthless and we say it is out of the money. I should say exercising the call is worthless, because as you will learn in your further finance studies, there's also speculative value to calls. We're talking purely about the intrinsic value here, what you can get for exercising the option now. So what does an increase in S sub t, the stock price, do to the value of the call? Well, it's going to increase the value of the call. Assume, first of all, that the stock price is higher than the exercise price. Every dollar increase in value in S sub t will add $1 of value to the call. But what if the call is out of the money by more than $1? Then a dollar increase would not impact the value of the call. What about changes in the exercise price? Well, you're subtracting the exercise price here, so for options that are in the money, the lowering of the exercise price by $1 will increase the value of the call option by $1. Now, if it's out of the money by more than $1, it's not going to affect it. But it also means that you are closer to being in the money if your exercise price is lower. And so as someone who owns a call, you would like for the stock price to be as high as possible and the strike price or exercise price to be as low as possible. The profit from exercising a call option depends on how much you paid for it. In our last discussion, we talked about the payoff from exercising a call option. That's just talking about the money that comes in when you exercise the option. However, we must also consider how much we paid for that option in order to know what our profit is. And so that's why we're subtracting C sub 0, the option premium that we paid, from our call option payoff in order to find the profit from exercising the call option. And so you'll see that the profit changes mirror the payoff changes. As a payoff goes up by $1, so does the profit. So that part doesn't change, but let's talk about C sub 0. Obviously, the less you pay for the option to begin with, the greater your profit. And so what we would prefer is a low C0 and a high C sub t, because that would give us the greatest profit. Now let's talk about the payoff from exercising a put option. Put options and call options work in the opposite direction. And so you may notice this looks very similar to the payoff from exercising a call option, with one difference. we now have exercise or strike price minus the stock price. This is exactly flipped from what we saw with the call option. And that is because the payoff from a put increases as the stock price drops, as opposed to the payoff on a call option increasing when the stock price rises. And so we see it's just the maximum of the strike minus the stock price, or zero. In other words, if the strike price is less than the stock price, then you will see no value here at all. The maximum would then be zero because this term would be negative. However, if the strike price is above the stock price, then you can exercise this thing and have a positive payoff. So what happens here if the stock price rises? Well, assuming that you're in the money, an increase in the stock price of $1 will lower the payoff by $1. What about the exercise price? Well, the higher the exercise price, the more valuable this option is. And so you see it's exactly the opposite of the call option, where you wanted your strike price or exercise price to be lower. And what happens if E, the exercise or strike price, is less than S sub t? Well, that left-hand term becomes negative, and so the max of those two terms would then be zero, and your payoff would be zero. Now let's talk about the profit from exercising a put option. The profit from exercising a put option is simply the payoff minus the original option premium that you had to pay to buy the option. So of course, as P sub 0 is lower, your profit is higher. As P sub 0 is higher, your profit is less. Ideally, we would want a high P sub t and a low P sub 0 to maximize our profit from this options transaction. Finally, let's talk about put-call parity. Put-call parity shows the relationship between the value of a put, the value of a call, the value of a share of stock, and the strike price given the time to expiry and the current risk-free rate. Let's walk through those things. P sub 0 is just the put value. S sub 0 is the stock price. C sub 0 is the call value. These are all happening at the same time 0. E is the strike price. Now, this is the same strike price for both the call and the put. And T, the time to expiry, is the same for both the call and the put. And the word expiry may be confusing to you if you're an American, because this is actually the British way of saying expiration. In fact, if you travel to the UK and you look at the dates on baked goods, you may actually see this word instead of expiration date. It will say expiry. And then R is the risk-free rate. Okay, now that we have all of those things identified, let's see what we can do with this formula. Before we start messing around here too much, I want to explain what this is. This is the exponential. And the reason the exponential shows up here is that our formula assumes continuous compounding. And when we are doing continuous compounding, the present value is equal to the future value divided by e to the RT. Keep in mind that this exercise price is something we're going to be receiving in the future at time t. And so we have to find the present value of that. How do we find the present value with continuous compounding? We take the future value, divide by e to the RT. Now that we have that squared away, let's go through and do some manipulation of this equation. First of all, it's really easy. If I want to find the value of P sub 0, I just have to subtract S sub 0 from both sides. So I'm going to do that, and it gives us this formula right here. Notice S sub 0 disappears from this side because it cancels out. We can also solve that formula above for C sub 0. It's equal to P sub 0 plus S sub 0, and we subtract the strike price divided by E to the RT. We could also find out what is the value of the stock at current. All we have to do is subtract P sub 0 from both sides. And finally, we can figure out what is the strike price. We just subtract C sub 0 from both sides, which gives us the exercise price or strike price divided by E to the RT. It's equal to P sub 0 plus S sub 0 minus C sub 0. Now, if I want to get E, or the strike price, by itself, all I have to do is multiply both sides by E to the RT, and that gives me the exercise price or strike price for both the put and the call.